Morning everyone. Today I will explain one sum from the chapter relation. Okay, how to show a relation is equivalence relation. A relation R in the set Z of all integers defined as R. How R defined? R defined like this way: x comma y, where x minus y is even number. Even number means divisible by 2. And you have to show that this R, this relation is equivalence relation. And we know that equivalence relation means it should satisfy three relations: reflexive, symmetric and transitive. Now one by one do the reflexive, symmetric and transitive properties. Okay, now firstly write down the relations R x y. X minus y is even number means we all know that even number means divisible by 2. Now first reflexive. To show reflexive we have to choose two same number from the set Z xx. Now we know that x minus x means 0. 0 is obviously divisible by 2. 0 is divisible by I think any number. You all know that 0 is divisible by any number, that means obviously divisible by 2. Therefore x minus x is belongs to R. Therefore R is reflexive. Now for symmetric you have to choose two different elements, x and y belongs to Z, and we assume that x comma y belongs to R. X comma y belongs to R means x minus y is divisible by 2, and since x minus y is divisible by 2, that means obviously y minus x is also divisible by 2. If x minus y is divisible by 2, that means y minus x is also divisible by 2. Therefore y comma x belongs to R. We choose x comma y belongs to R. We show that y comma x belongs to R. That means R is symmetric relation. Okay. Now transitive. Transitive relation what? Transitive relation means you have to choose three elements from integer z, x, y, z, and you have to assume x comma y belongs to R and y comma z belongs to R. Since x comma y belongs to R, that means from the relation x comma y belongs to R means x minus y is divisible by 2. X minus y is divisible by 2. Since x minus y is divisible by 2, that means we can write x minus y equal to 2 into something. 2 into something means 2k1, where k1 belongs to integer. Okay, k1 belongs to integer. Now come to the second part. Y comma z belongs to R, that means y minus z is divisible by 2. Y minus z is divisible by 2 means, similarly, y minus z is divisible by 2 means y minus z is equal to 2 comma k2. K2 is also integer. Now from 1 and 2, what you can say? In 1 we got x minus y equal to 2k1, and in 2 we got y minus z equal to 2k2. That means just add both. If we add both, that means x minus y plus y minus z equal to 2k1 plus 2k2. Add 1 and 2. We get x minus z, because y cancel out, equal to 2 common k1 plus k2. See, x minus z has a factor 2. That means x minus z is divisible by 2. Therefore x comma z belongs to R. That means R is transitive. Since R is reflexive, symmetric as well as transitive, that means R is equivalence relation. Okay, thank you everyone.